Okay, so now this is a continuation on DNS. DNS is a domain name system. That's what DNS is, right? It's a domain name system that is intended to translate, domain names or human readable domain names into machine readable IP addresses. Now, this is a fundamental service of the internet that converts these domain names. Like for instance, uh, you have a domain name like www.google.com. That's a domain name. It's a system which is designed to translate that or convert that domain name into a numeric IP address, right? And I'll explain why this is important, right? So the service basically allows users um, to access websites, to access email service, as well as other online services without any memorization of numeric IP addresses. Now, the point behind it, this domain name system or DNS, the point behind it is the fact that we tend to remember domain names like www.google.com far much easier than any numeric IP address. Like think of any IPv4 IP address, like let's say 16.3.7.5. That's an example of an IPv4 IP address. Now it's way easier to remember the domain name google.com than this numeric address, right? But on the other hand, you have computers which actually require these numeric IP addresses in order to route internet traffic or route data packets. So now you need the domain name system in order to act in between these two, right? To act as a distributed hierarchical directory service that does this conversion between domain names as well as numeric IP addresses, right? So that's the role that is played by the domain name system, right? So let's say the user, or I type into the browser, I type google.com, right? So what happens is that the domain name system will translate this domain name google.com into a specific numeric IP address, whether it's IPv4 or IPv6 IP address, it doesn't matter, right? It would translate it into an IP address, and then that's how the browser would actually connect to the server, right? And so the domain name system itself, in order to organize, because remember there are billions of domain names worldwide. Uh, there are also billions of devices uh, worldwide over the internet which are connected to various networks or the internet, right? So the domain name system uses actually a hierarchical tree-like structure in order to organize these billions of the domain names. Like think of any domain name like google.com, microsoft.com, and so on, right? Uh, so it organizes all these domain names using a hierarchical structure, and that hierarchical structure actually goes from is organized in terms of servers, right? You have root servers, and then from there, there are top level domain servers, and then the sub or second level domain servers, then the subdomain, followed by the host itself, right? So looking at the hierarchical structure of the domain name system, or DNS, right? Firstly, you have like the root server. Now, the root server is at the top of this DNS or domain name system hierarchy, right? And what it actually stores, it stores like pointers, which are pointers to the top level domain servers, or TLD servers, right? So these root servers actually globally, there's like 13 logical root servers, which are all logical root server groups, which are named A to M, right? So you have 13 groups named A to M, and each of these groups have many distributed physical, root servers all over the world, right? So consider like an example like query flow, which goes like you have a resolver resolving domain name like google.com. If that resolver is resolving the domain name google.com, it first needs to contact root servers about top level domain or TLD information. That's the first root server in the uh, DNS hierarchy, right? And then the second would be top level domain servers, and these are very common, right? And I will explain why they're very common. Now, these top level domain servers or TLD servers actually manage all the domain names under a specific top level domain server, like uh, .com, .net, .org, .gov, .ac, .za, .uk, .jp, and so on. And so you have two types of TLD servers. You have generic ones like your .gov, .net, .com, .ac, and so on. And then there's country code TLD servers, right? Like .za, .uk, .jp, and so on, right? And all these TLD servers, what they do is they direct all the queries to authoritative name servers for domain names, right? And then on top of that, they are authoritative name servers. So you have root servers, there are top level domain servers, and then the authoritative name servers. Now, these authoritative name servers actually contain or store information in the database regarding the actual DNS record or domain name system records for a particular domain. Now, a domain name like google.com would have various DNS records, right? And I'll go into the types of DNS records just now, right? And what these authoritative name servers are responsible for, they answer all the queries regarding the domain names which are specifically under their authority, and the several types uh, of these DNS records which are contained in authoritative name servers. Like you have the A record. The A record is there to convert the domain name into an IPv4 or IP address, and then you have an A record, your four A's, right? A record that maps or converts domain names into IPv6 IP addresses. Remember, there's two types of IP addresses: IPv4 and IPv6 IP addresses, right? So you have these two records converting domain names into IPv4 or IPv6 IP addresses. There's other records like MX record, that's the mail exchange server, and then there's a CNAME record. CNAME record would be the canonical name or the alias name for the domain name. All right, and there's also an NS record, which would be the name server, for a particular domain, right? So those are authoritative name servers, right? The root servers, they are top level domain servers, and then from there, these are authoritative name servers, right? Uh, Now, DNS, the domain name system, uses two types of queries, recursive queries as well as iterative queries. Now, in a recursive query, the DNS resolver actually asks the server to return the final answer. The final answer is the final IP address for a particular domain name. Now, it asks the server to return that final IP address. What that means is that the server may then have to query other servers on behalf of the client until that final IP is found. And this type of querying or recursive querying is mainly used by end user devices, right, which are querying local recursive resolvers, right? So let's say, for example, we have a user's computer which is querying an ISP DNS resolver, right? That DNS would actually query the root server, the TLD server, as well as the authoritative name servers on behalf of the client until the final IP address is returned. And then on the other hand, there is iterative queries, right, which are slightly different from recursive ones, right? In an iterative query, what happens is the DNS server actually responds with the best information that it has. All right, and it's often the case that it often refers the resolver to the next server, which means that the client must then query the next server, right? Because it's been referred by the server to the other server, right? Right, and then this type of querying or iterative querying is mainly used between DNS servers, right, in order to propagate information more efficiently. So what would happen is that you would have a DNS resolver or an ISP resolver, querying the root server, and then the root server would actually respond with the TLD server IP, right? Uh, because it's referring the resolver to TLD server. That's why it responds with the TLD server IP, right? Then the resolver would query the TLD server, right? When querying the TLD server would respond with the authoritative name server IP, which means it's referring the resolver to the authoritative name server. Then the resolver would query the authoritative name server, and then the final IP address or that final numeric IP address, whether it's IPv4 or IPv6, would be returned. So those are two types of queries, recursive as well as iterative queries, right? And then there's domain name system caching, right? I'm sure you're familiar with caching. You see it on the internet. It's very familiar, right? So DNS caching, in order to reduce latency as well as server load. All DNS responses are caged or stored or saved, for at various levels. If client side caging, you have server or ISP resolver caging, as well as intermediate or between, DNS servers, right? So what happens at the client side or the client cage level? What happens is that the browser or the operating system or the OS would actually cage or store all the recently resolved domain names, right? And then for the ISP resolver cage, what happens is that the local recursive resolver would actually store all the results or all the recently resolved domain names for its users, right? This is to save time, save resources as well, and between intermediate DNS servers or between DNS servers, the caging is set for a limited or TTL duration or time to life duration, right? After that, yeah, the cage actually expires, right? So DNS caging actually leads to faster domain name resolution for repeated queries. It also reduces internet traffic as well as server load. It improves the total or the overall efficiency as well as reliability. And putting this into context, let's say there's a TTL duration or time to life duration of 3,600 seconds, which is equivalent to 1 hour, right? So what that means is that the the results or the recently resolved domain name would actually be caged for 1 hour, right? Or the IP address which has been that the resolver has found would actually be caged or saved for 1 hour before recurring is actually required, right? So that's the DNS caging or a cage. If familiar with that term on the internet, right? Then the DNS resolution process, how actually domain names like Google.com are actually resolved, meaning that how the resolver actually finds the numeric IP address for that particular domain name step by step. So firstly, there's a user which types the domain name onto the browser, and then the browser what it would do is that it would immediately check for local cage, right? If it exists, then it would immediately say return that final IP address. If it's not found, on the other hand, if it's not found, then the OS or the operating system has to query the recursive resolver, which is usually the ISP DNS, and then the resolver would query the root server, and then the root server would respond with the TLD server IP for .com, Remember, .com is a TLD server, which means it's actually the root server is actually referring the resolver to the TLD server. That's why it's responding with that TLD server IP for .com, right? And then it would the resolver would actually query the TLD server, and if it's not found in the TLD server, if the final IP address is not found in the TLD server, then the TLD server would respond with the authoritative name server IP address, and then the resolver would query the authoritative name server, and then the final IP would be found in that authoritative server, right? That numeric IP, let's say 23.7.3.1, like that's an IPv4 IP address, so that authoritative name server will return that numeric IP address. And then what happens after the resolver would actually return that numeric address to the client. And then that's where the browser actually connects to the server. And that IP is saved or caged or stored for a set or a limited TTL or time to live duration. So that's the whole, DNS resolution process. And there are several reasons why the domain name system is actually crucial. If is a crucial service of the internet, right? One is it's user friendly navigation, because it does the conversion between human readable domain names like into specific numeric IP addresses, right? It does that conversion for you, right? So it has a user-friendly navigation, right, feature, and it also quite scalable because it supports billions of devices to connect it to the internet, as well as billions of domain names worldwide. DNS also has a distributed architecture, which actually increases reliability and also prevents single point of failure. It is also very efficient in terms of recursive queries as well as caching, DNS caching, because recursive resolver as well as DNS caching actually reduce network load. That's why DNS is very efficient. So that's why it's important as well. It is also very flexible because it supports a multiple of various record types, which are suitable for websites, for email, for file transfer, for streaming, and so on. Many services on the internet. So you see that this domain name system, aka DNS, is actually the phone book of the internet, because it converts billions of domain names onto IP addresses. It's like having a phone book that's or contact list on your phone, and each and every contact is assigned a specific phone number, right? That's the domain name system. So that contact list is like a domain name system, because it stores the list of contact, and it stores their respective phone numbers, right? So in this case, DNS would store the specific domain names as well as their numeric IP addresses, right? So it's hierarchical structure as well as recursive with iterative queries, and also um, um, caching or DNS caching. I actually guarantee or ensure fast, reliable as well as scalable internet navigation. Thank you. See you on the next one. Cheers.